Okay, next topic is X-ray diffraction of crystals. So, how come they analyze crystal in reality? So, this is one of the techniques using X-ray diffraction. So, so that's maybe the question, the answer when we were asking ourselves how they come up with a knowledge to find the basic unit cell. So, as if in terms of storytelling, this is one of the key because they can already figure out um, the distances between atoms, and this is one of the technique that is being used using the X-ray diffraction. So the concept actually is um, just like this. The concept is like this. As you can see, you have a beam of light. This is actually, you can imagine it as a laser or a particular. This actually is an X-ray kind of a beam. So imagine, basically this cannot be seen because an X-ray, when it looks like just a plain yellow light, but actually X-ray cannot be seen because that's a wavelength which is higher than the visible spectrum of electromagnetic waves. So this is an X-ray tube. Basically, this emits an X-ray. So imagine that it's just a particular one spot or one laser. So you can just see, and it hits a crystal, meaning a solid, which is crystalline in nature. It is a well-defined form. You could just imagine a salt, sodium chloride, asin, diba? A salt. When that X-ray tube or that X-ray or X-ray beam hits that crystal, they found out that it makes a pattern, a dispersed pattern. So how come that there's a pattern? Because those parts of those X-rays are hits. Usually, the X-rays hits the atoms, the nucleus of the atoms, because um, that's how that this X-ray don't pass as a single beam. Maybe it has a single beam. You look at this big circle. There's a big beam, but you can see that some of those actually is when it hits a particular atom, such as like this, meaning if that X-ray is counteracting that atoms, so those pattern is the atoms themselves. I mean the nucleus of the atoms themselves. See, if that is the atoms, the nucleus of the atoms themselves, and it will tell us the pattern, then according to this, it developed the scientist who made this, which is Bragg, because we call this a Bragg's equation. Bragg, Bragg. See here, the pattern that he had seen, I mean, is just a, as you can see, he modeled this one from trigonometry. Again, you are under 1B, marine bio is under me in calculus. As I was telling you, the the usage of your mathematics really for you to develop um, models for anything in nature. So this one is an X-ray um, hitting a crystal. So an X-ray hitting a crystal and then imagining it like this. Of course, they haven't seen this. They're just imagining it like this. If what is hitting, because um, an X-ray is an electromagnetic wave. So basically, it will react also to electromagnetic wave um, at the same property. So one of the things that they've seen, because X-ray would actually hit a, or would react, meaning those pattern is contributed by those nucleus themselves, where the proton and neutron is. That's why it is it exposing ourselves to X-ray is not good. Why? Because as you can see, what constitute our atoms are neutrons. If electrons, then it would not be that hard. Why? Because every chemical reaction involves electrons. But now, when neutrons are already involved and neutrons and protons are already involved, then it would be radioactive. That's why we don't want to be hit by an X-ray always, because um, it may destroy our cells, protons and neutrons, therefore killing the cell itself, or maybe making a um, what do you call this? An evolution, or what do you call this? This malady with respect to our chemical makeup, mutation. That's the term. We don't want to be exposed with radiative materials, high energy like X-ray. We are only allowed to make an X-ray once a year or maybe twice, because it really interacts with protons. So these patterns is because of those nucleus, and because of that, he developed the distances in terms of using that X-ray. That X-ray, that wavelength of X-ray is related to the distances of atoms, and that relationship is twice the distance multiplied by the sine theta, which is from the trigonometry. Of course, he got it from this from this illustration, is equal to n. However, the meaning the pattern with respect to n, meaning it has a particular distance. When you say n, that should be 1, 2, 3, 4, 5. Meaning um, this would be probably 1n, and this would be a probably 2n. And this would be probably, I mean, the n here is 1, the n here is 2, the n here is 3. But it only means that that n is at constant proportions. Because as you can see, the arrangement of crystals, because it is well defined, and it has a good structure. I mean, it has a well defined structure, not like amorphous, meaning we're hitting a constant gap of nucleus. So that's why he developed this one. If you know how to read mathematics, that n symbolizes that, and this lambda is actually the wave, the wavelength, of your X-rays. Okay. So anyway, I think in physics this would be a much complicated discussion, but in chemistry we only have to use this one. And even in of course, there are scientists who uses these equations to find the distances between atoms, because all atoms now are already found, the distances between them. So we're just looking back at the history. Okay, so we'll go to problems. May I pause first? So we come to problem. When X-rays of wavelength, so the wavelength is given, 0.090, are diffracted by a metallic crystal, the angle of first order diffraction when n is equal to 1 is measured to be 15.2 degrees. What is the distance in picometers between the layers of atoms responsible for the diffraction? So your problem is D. So if we go back to our 2D sine theta n lambda, let's just see what is. Of course, the angle is given. You can just see what are required for this. This one's already given, of course. This one's already given and is equal to 1. This one is the X-ray itself, the wavelength of X-ray in picometers, and therefore we can find D. So anyway, we only have to supply the theta. Theta is 15.2, which is 15.2 degrees. N is equal to 1, and lambda is equal to um, lambda is 0.090 nanometer. 0.090 nanometer. So nanometer is times 10 to the negative 9. Okay, basically we can solve that one. You can say that D is now equal to N multiplied by lambda divided by 2 sine theta. And then we substitute N is equal to 1 multiplied by lambda 0.090, and then we can resolve probably the nanometers into um, meters, since the problem didn't tell us what would be our units. What is in picometers, so the distance should be in picometers. So we should resolve this to times 10 to the negative 9. This is again the nano. This is the nano, and then we put the meters. Okay, And then after that, we say 2 sine and the angle which is 15.2 degrees in terms of degrees. Okay, so anyway, 0.090 times 10, since we need a pico, that should give us a negative 12. So for us to grab that negative 12, we should put times 10 to the negative 3. Positive 3. 12, negative 12 plus 3, that should give us the negative 9. Okay? And then we put meters. So this guy here has been splitted into 2. Okay? The 12 minus 3 is equal to negative 9. So why did you do it, sir? Because I need this one. This is the pico. This is the pico. And the problem tell us that your answer should be in pico. Okay? 2 sine 15.2 degrees. So all in all, that should be 0.090 times 10 to the negative 12. Sorry. Control Z. I need that negative 12 times 10 to the 3. Tapos, divided by 2 sine 15.2 degrees. Now, our unit would be that 10 to the negative 12 pico. And then the meter, that should be the picometer. So, you get the calculator. You get the calculator, 0.090 exponent 3. And then you divide it by 2 sine 15.2 degrees. So, the answer would be 172 picometers. So that should be the distance of those from the problem. What is the distance in picometers between the layers of atoms responsible for the diffraction? So meaning the layers of atoms, the nucleus itself, the distance between nucleus to nucleus of the atoms in crystals. So that's what the problem tells us. Okay, so you also have examples of the LPs. So kindly check them out. Please share to your classmates, but don't subscribe. Thank you guys for listening.